Hello, everybody.
Hello.
Hello.
Hello. So welcome to our regular group meeting. Just as a reminder, I record those group meetings, but I will not publish any recording of you without your explicit consent. So typically I ask them by email if you allow me to share the part of recording that contains you. Okay, so before we start with discussing some master thesis projects, let me welcome our guest today, Vincent. Hello, Vincent.
Good morning. Thanks for the invitation.
Sure. Yeah, Vincent, maybe you would like to introduce yourself and your topic?
Yes, I would love to. My name is, should I share a presentation maybe?
Yes, I made you
Okay.
co-host.
All right. So, yeah, my name is Vincent, and I'm from Berlin, and I'm an engineer, and yeah, I did some study in Germany. It was called climate engineering. It was like integrated planning for buildings. And I had to focus on energy data for energy forecasts. After I did my master in Berlin, and it was also an integrated course about building energy and information technology. And I did my master thesis about pattern recognition in the manufacturing industry. It was about the printing industry, and that's also the place where I work today as an energy manager. And yes, my tasks are like to make the modernization of energy metering and data processing and energy efficiency measures. And yeah, the background, but why did I contact you is that we have like I told you, the printing industry, which has high requirements for indoor air conditions for temperature and humidity. And we have a big plant, which is a full air conditioning system, which runs all the year, 24/7, and using standard control strategies. And this leads to high energy consumptions, which is a big challenge for the energy targets of the company. And in my master thesis, I did some research and some analysis of the energy and BMS data to detect seasonal and temporal consumption patterns. Yeah, I'd like to see on this picture. And I did some correlations analysis for the heating and cooling consumption of this ventilation system. And I also tried to find some operation faults, like simultaneous heating and cooling, which is yeah, leads to energy consumption which is not necessary. And so in short, the consequences of the master thesis was to make retrofitting of sensors, because the database before was like synthetic energy data, and now after 1 or 2 years we have like real measurement data. And yeah, and that was one consequence, and the other consequence was that we have to modernize the energy data processing. Yeah, like I told you, these are my actual tasks right now. Right. And here we can see like the basic components of the full air conditioning system. I think second. we have different components like the rotary heat exchanger, which is the heart of the plant, because we have a recovery of temperature and humidity, which is really important for the efficiency of the plant. We have different registers for preheating, cooling, humidifying, and post heating, and we have some ventilation, some fans. I mean, and this is like the state of today, that we have now energy meters here. So it's a lot of data to analyze and to use. And beside the energy meters, we have a lot of BMS data, like target values, actual values, and limit values for the different temperature and humidity sensors. We have valve openness signals. We have volume flow of the system. So and the thing is that actually nobody in the company uses the data to do something. They just let the plant do her job, its job, and it leads to a lot of energy consumption. And I think nowadays we have some more tools, maybe to make it more efficient with AI tools. And that's the main idea, that AI tools can be used for optimizing the control strategy and to minimize the energy consumption. Yes, and how can it be done? Maybe by learning from the causal relationship between the weather, outside weather data, which leads to different BMS data signals like valve openness, and now that we have the energy meters, we also know which energy consumption results. And my plan now is to make the existing ventilation system, to map it in a simulation model, and to testing and comparing different control strategies. And in the end of the day, it would be nice to implement it in the real building. And the current status is that I did some literature research, and I tried to make some interviews, and I found this topic, deep reinforcement learning approach for HVAC. So I was really interested when I read it, and so I just wanted to start the contact and maybe to get some feedback about problems and or how can it be done well. And that's it for short. Thanks.
Yeah, thanks a lot, Vincent. Very interesting application. Are there any questions or comments from the audience?
I have a question about the energy profile of this plant. I mean, it's basically predictable, or it has a regular stable energy consumption pattern?
It has a regular seasonal energy consumption pattern, for sure. The heat registers, they work in the winter time. The preheater registers, they work in the summer time, as well as the cooling. You can see basic patterns, but I didn't try till now to make a prediction of it. Maybe it would be a good step, a next step. So far. But the temporal patterns are not really predictable, I guess. It depends. The difficult thing on all this is that we don't only have the various outside air temperature and humidity, but we also have the different internal gains of the production hall, the different machines. And maybe I should maybe I have to use also the data from these machines to put it in a simulation model, so I know what's going on outside, what's going on inside. Yeah, to have a better picture of the whole system. But for the first step, I wanted to start easy, to just take the outside air conditions and just the plant. Yeah.
Thank you.
And why would you like to have a simulator? It seems you have already collected a lot of data.
Mm-hmm.
So over which time period do you have the data from the plant or from the building? Over a year, 2 years?
The BMS data is like for many years, like, I don't know, 10 years.
Mm-hmm.
But the new energy data measurements, it's like not even 1 year.
Mm-hmm.
So
Mm-hmm.
I think I have to wait a little bit till there
Yeah.
are more data, and in the meanwhile, I just wanted to make the raw concept of how to use it wisely. And yeah, and the simulation, I think a simulation is a good idea, because in the real building, I cannot just change the strategy, because if there's some problems, we have a huge problem in the manufacturing.
Mm-hmm.
So yeah, that's why I want to try some different strategies in a simulation.
Mm-hmm.
And right now I'm reading like Energy Plus documentation, how to do it. It's seems to be a little bit complex and difficult, but in the literature research, I saw that many people did it, so I'm optimistic that I can do it also as well. And my boss in the work, they appreciate what my idea, and that I can do some research in the industry. So I think the basic conditions are good.
Yeah.
I just have to move on, and yeah.
Yeah. So that I understand correctly, the goal is from an engineering or machine learning engineering perspective, you want to read in all the sensor data, the temperature sensors, all that you know about the machines and the job that will be done by the machines within the nearer future, within the next hour, or let's say the next 20 hours. And based on all this information, you want to predict, should I now open or should I now turn on the AC or not?
I thought about that the machine learning algorithm maybe can learn if you have certain outside conditions for temperature and humidity. It can learn how the plant reacts, like how many valve openers do we have on the heating register, on the cooling register, on the ventilation, on the fan. And so you can make a model and say, okay, on these conditions, the plant reacts like this, and this leads to this and this energy consumption. And maybe with reinforcement learning, it's possible that the algorithm can iterate different steps and possibilities how to control the plant, and to reach the goal, the supply temperature and humidity by minimizing the energy consumption. Was the raw idea.
Yeah. I mean, you could also try to, tuning and implementing reinforcement learning and deep reinforcement learning algorithms might be challenging.
Yeah.
So it may take a bit more expertise and time, but what I try to think often is, isn't it also possible to formulate as a plain supervised machine learning problem? So you want to predict some quantity of interest. The quantity of interest would be, should this switch now be turned on, whatever this switch is of the control system. And the problem then is you need labeled data. So you need to know similar settings. In a similar setting, turning on the switch was the right decision. So, but but I was thinking you could use this historic data that you collected to build such a labeled training set. So you could look at the historic recordings. Okay, in this condition, with this outside temperature, the control that was currently used, I guess it's not using AI or anything, but the control turned on the switch, and it regulated well, so it worked. So you could try to cherry pick previous conditions where turning on that switch showed a good effect. So the challenge here would be, the hard work would be to find this labeled data points. So to find previous conditions during last year where you clearly see, okay, turning on the switch, this switch here was good, or turning on this switch was bad.
Okay.
And that's how you could assemble a labeled training set and then run any linear regression model or non-linear regression model using basic Python libraries like scikit-learn.
Okay. So in your opinion, it's not necessary in the first step to make a simulation model, just to...
Yeah, I like to first massage the data, so to reformulate the problem so that I can use my basic tools like a linear regression. So I try to remodel the application such that I can use a given tool. And not try to apply the most powerful tool in the beginning. So deep reinforcement learning is maybe among the most powerful tools. Also most challenging to tune, maybe. So for linear regression models, I have pretty good understanding. I know how much training data you need in general when you have some estimates of covariance, of sample covariance and stuff. So I would try to first reformulate it in a supervised regression problem. But the challenge here is then how to get labeled data. So you would need to sit down and look at all these traces of the time series. I guess they are recorded on a second interval or even finer.
Oh, no, it's not that. It's like 15 minutes.
15 minutes, yeah. Then hopefully you see all the measurement data, and then you see the control turned on that switch, and then you see, okay, it went into the right direction.
Yeah.
So you would then have this, for this time window, you have a labeled data point where you know, okay, when you have this condition before, a few hours before, then turning on the switch was good. So the thing that you want to predict is, should I turn on the switch, yes or no? So this is actually it's a binary classification problem. So it's not linear regression, but logistic regression you might want to use.
Okay. Logistic regression. Okay.
Yeah. But for this, I mean, this super interesting. And would there be any chance to get a part of the data that you could share the data, or is this sensitive?
It is definitely sensitive.
Yeah.
But I think if we can make a cooperation, like officially, it would be definitely possible. I had to, I think we need a NDA or something.
Yes.
Yeah.
I easily sign NDAs, no problem.
Yeah, in the end of the day, it's machine data. It's not personal data or production data. Yeah.
Well, it depends what you produce there, maybe.
Yeah. Different things. We produce like ID cards, for example, German ID cards.
Okay.
And the money, euros.
Euro. Oh, I'm hearing.
Yeah, and we have a lot of production halls like which are similar. So it makes sense to face this topic.
Yeah, so maybe you would ask somebody who is coordinating the data management if there's any chance to get at least a snapshot of the data, and I could try to look at this more closely.
Okay, that sounds very good.
Yeah, so my advice would be to invest more in this data wrangling and reshaping data, so you can use super simple machine learning techniques then implementing this deep reinforcement learning, for which you might need a simulator because you need to generate more training data artificially.
Okay, that was the reason why they use. Okay.
And they had a simulator, as far as I remember, in the master thesis. They had one available from the company.